Imagine you are given a binary tree. Your job is to figure out if the tree is balanced or not. But what does it mean for a tree to be balanced? Okay, a tree is balanced if 1. For every node in the tree, the height difference between its left subtree and right subtree is no more than 1. Both the left and the right subtrees of every node must also be balanced. Okay, let's try to break it down. Height of the tree. So this is the number of the nodes along the longest path from the root of the tree down to the farthest leaf node. 2. If node if one side of the tree is much deeper than the other, difference in height is more than 1. The tree is unbalanced. So here this is unbalanced because there's 1 and this is too many. Okay, so let's try to take an example for this one. For node 3, left subtree rooted at 9, which has height of 1. Right subtree rooted at 20, which has height of 2. Okay, the difference is 1, so it's balanced. For all other nodes, the height difference is also less than or equal 1. Okay, let's look about this example. So for the root 1, we have left subtree 2 and right subtree 2. The height here is 1 and the right here is 1, 2, 3, is 4. So the tree is not balanced at all. Okay, how we can solve this? We can solve this one using like a recursive function, like yeah, we can do this one using a recursive function. Yeah, this is what I'm thinking about. But let us try to think more. So as we said before, a binary tree is height balanced if the left and the right subtrees of every node differ in height by no more than 1. The tree must be balanced at every node. The approach should be to determine if the tree is height balanced. We use a recursive function. First, we calculate the height of the left and right subtrees of every node. If the height difference between the two subtrees is greater than 1, the tree is not balanced. The 3, we use a special value like -1 to propagate unbalanced status up the recursion up the recursion stack. So how we can do this one? We can start with a function we called const. I will call check height. Let's call it only check. Okay, I guess we only take a node. We take a variable, we called it node arrow function like that. And yeah, so we use a helper function to calculate the height of the tree and check the balance. As always, we are creating this function will be a recursive function. So we should put a base case, and the base case will be like, the base case will be empty tree has height of 0. So if there was no node, we return 0. I guess there's a problem here. Yeah, we return 0. Okay, so we need to recursively get the height of the left and the right subtrees. How we can do this one? Okay, so we call the check function again on the left and the right. So we const left height will equals the check function, and I'll put node dot left, and I will have also right height. It will be node dot right. y, exactly. Okay, so after going recursively to the end of the right and the end of the left, we will see, like, we will do the next, like, if either subtrees is balanced, propagate -1 up the recursive stack. Okay. Let's try to understand this one, because it's, I guess this is not that easy. Okay, so I will put the code. Let me just put this all of the thing here, and I will describe it one by one. So if left height equals -1 or the right height equals -1, or math dot absolute left height minus right height is bigger than 1, if this case is all these cases met. Let me just, yeah, we need to return -1. Okay, why did we do all of that here? So this code snippet is part of the solution that we talked about. We need to check this one. So this snippet is used inside a recursive function, which is called the check, and we need to calculate the height of the left and the right subtrees of each node. We need to determine if subtrees rooted at the current node is balanced. Let's try to explain. The first condition. Here this check is if the left subtree is unbalanced. So if it's equal -1, or like if the check function previously found an unbalanced subtree while calculating the height of the left subtree, it would have returned -1. This value is propagated up the recursion to indicate that the entire tree is unbalanced. Condition number 2. Similarly, this checks if the right tree is unbalanced. If the check function previously found an unbalanced subtree of the right, it would have returned -1. The third condition, this check the height difference between the left and the right subtrees of the current node. If the height difference is greater than 1, it means the current subtree is unbalanced. So if any of these conditions above are true, the function immediately returns -1. This indicates that the current subtree is unbalanced and there is no need to continue further checks for this subtree. The -1 value will propagate up the recursion stack, signaling that the entire tree is unbalanced. Why this will work? First, it efficiently identifies unbalanced subtrees by leveraging recursion. By returning -1 immediately when an imbalance is found, the function avoids unnecessary calculations for the rest of the tree. The use of math the absolute, which is left height minus right height, ensures that the height difference is calculated correctly regardless of which subtrees is quite taller. Okay, so we have it like this, and we return -0, and here we need to return the height of the current node. So we return math.max left height and right height +1 for the current node, and we need to call this function. So we do like return check if check of if check root, and we put root the root node doesn't equal -1. If it will be true or false. Let me try to run, submit. Okay, it's working perfectly. So yeah, I guess this was the trick. All the trick lives here. So yeah, that's it for this solution, and I hope you like my content. See you in future problems, guys.